Hey, this is Professor Harvey. It's another weekend, another soccer tournament. I'm here in Pasadena, Maryland, watching some soccer games and doing some work from the car in between because it's the 21st century and I'm a consultant and I can do work wherever. The curse of having a job where you can do work from any place is that you end up doing work from every place. So I want to take a little more looking at this Wireshark capture that we were looking at before. So we said that we really were interested in these particular conversations here. I took some notes about the conversations we were interested in and the IPs, right? So these are the victim and the attacker, and some notes on the sessions, and I'll show you. These are the notes. I think we took these notes during the last one. I'm sorry. These are the new notes. Okay, yeah. So these are the new notes I took, and we're going to see what. So these are the sessions that we were interested in, starting with this first really big session. So let's take a look at these and let me explain some of what you're seeing here if you've been looking at these, so you can get an idea of what they are. Again, the great thing about this is the conversation view in Wireshark, and if you weren't with us the last time, all you have to do when you have a capture open is go to Statistics, Conversations, and you get this view, and you can see the conversations from the perspective of all the IP address conversations and then all the TCP conversations down to the port level. So you'll have multiple conversations between the same two IP addresses because they're different ports. So it's each TCP session is a separate thing in this view. And then what we did was we sorted here by the packets, right? Which ones were the longest. And we noticed also the duration is an interesting thing to look at as well. These sessions last for the entire time of the packet capture pretty much, right? These long sessions, or these long duration TCP sessions. And this one's really huge, so let's take a look at it. If you right click, go to apply as a filter, go to selected. A to B means it'll show just that one session, back and forth, right? A to B would only show one side of it, B to A would only show one side of it, A to any would show everything from that same port on IP address A to any host. And that's actually sometimes useful, but normally what we want to do is we want to do this. And when we do that, what it does is in the main Wireshark window, if we go back to the main Wireshark window, here, we, there, okay. So this is that session, right? So basically what it does is it just creates a filter for us. And when it's a long one, it can take a while for that filter to kind of fully take effect. And then here's this session. We can see it starts like you'd expect with a handshake. We have the handshake. It's SYNAC, SYNAC, ACK. And then here's where it gets interesting. First of all, the reason we were interested in this session was not just the duration, but the ports, right? And it's weird to see two higher level ports like this involved, because it means one of the machines is listening on that port, right? 25190 is listening on .69. .69 being the victim machine in this case. So the victim machine is running some kind of service that's listening on this port, which is weird. Other weird thing is what we see happens here. So we got the handshake takes place, and then the very first packet comes from the side that initiated the handshake, and it starts to push data. So it initiated the handshake and then it immediately just starts to push data to it. And so we can see it's unencrypted here, and this is an interesting packet. Let's take a closer look. What I like to do is we're really interested in just the data, so I would highlight that. So then this highlights just the data portion. This is all headers, and the part in blue here is the data. So here's the interesting part. The data starts with MZ, and then we see down here, this program cannot be run in DOS mode. this is what the beginning of any Windows program looks like. Pretty much any Windows.exe file that you get or .dll file, most of them will look like this. So it's just sort of the signature. They're called MZ files, or sometimes technically the name is a portable executable, is what the .exe format for Windows is, but it also often known as MZ because that's the sort of signature header at the beginning of those files. So what's happening here is this machine is connecting, and then it's immediately starting to push an executable down to the victim. Right, so the attacker is connecting to a service that's running on the victim on this weird higher port, and then it's pushing an executable file to it. The frustrating thing about this, I have to say, and I was trying to figure out how to solve this problem, is that this session is really big. So it's possible, this session is 52 megs, total number of bytes. It's 49 megs being pushed from so that's the interesting thing. So the bytes from A to B, from 199 to 69, it's only 2.9 megs. The majority of the data is coming back, so that's kind of interesting as well. But we can see this program being pushed down, and so what you see happening here is this is a full-size packet, right? And then this one is nothing but headers. There's no data at all. It's just an ACK, and that's the pattern you see. So you'll see, the side A, the attacker is pushing more data and just getting ACKs back. If you scroll down far enough, at some point that pattern will reverse itself. And this is a really long session. So now we see just the reverse here, right? So this is the victim pushing data to the attacker. And it goes on like that for the entire duration of the packet capture. And this is the lion's share of everything this packet captures, this one weird session. So I'm not sure what's causing this yet. We haven't done enough investigation to show what's causing it. But we know one thing that happened was that the attacker immediately pushed down that executable. We saw that. So let's look at these other sessions here. So these sessions are interesting because they are from the victim to the attacker on port 443. That's more typical of what you see in malware. Typically what you see in malware is that the victim is exploited, and then the exploit consists of telling that victim, hey, go out to this address and hit this URL, because it's difficult to get into modern networks, right? Modern firewalls are very effective. Most companies are pretty careful about what they put out on the internet or what they allow to connect in through the internet. So it's very difficult. You can't really just reach in from outside as a bad guy and try to attack someone's computer behind a firewall inside of a corporate network. But what you can do is you can, through a phishing email or other means, try to get them to click on something malicious. And usually what that malicious thing is just a small thing, and we call it like a downloader. So it's just a small piece of malware that reaches out and downloads a larger piece of malware. So this victim connecting out to the attacker is a very common thing that you see. So let's take a look at this session. Okay, so this is that new session, and it is from it's from a port that's sort of oddly low number, but that may be legitimate. We don't even know what the operating system is yet, so it's hard to say. So we see SYN, SYNAC, ACK, all pretty normal, and then here's what's interesting. So victim attack is talking to the malicious IP. So the victim is initiating this session, but the weird thing here is once the session is initiated, the server immediately starts pushing data down, which is not what normally would happen, right? If this is a normal web service, the client starts the conversation. Not only does it start the handshake, but it starts the whole HTTP conversation by saying, oh, I want to get this page, or I want to post something to this URL. But this is the reverse. The reverse is what was happening here. He connects to the server, and then the server immediately starts pushing down data. And look at what the data is. Same deal. It's an MZ, right? It's an executable file. This one's small enough. The other one was so large that I tried earlier to do the follow TCP stream, and it just wouldn't work. It just wouldn't work at all because it was so big. Wireshark just choked on it. I got 16 gigs of RAM, so Wireshark has trouble with doing that rendering of like follow a stream when it's really, really big. So if you look at this program, it's pretty typical in that if you scroll down a little further, if you've ever done any kind of disassembling or reverse engineering of Windows programs, you'll notice that you have the text header, the section headers here. Most Windows programs will have sections like a text section, which contains all the text elements, a data element that contains all the data elements, our data, which is relocated data, and then this is a relocate section. So these are pretty typical sections you'll find in Windows executables. So I'm going to kind of short circuit this so we don't take too much time on this video. Okay, so when you go down far enough, you start seeing recognizable text, right? And this is probably what this is the text section of this executable. And what you notice is all this OpenSSL talk. If you don't know what OpenSSL is, it's an open source library that's often used. It's often incorporated into other software to enable that software to do secure sockets layer or transport layer security or other encryption methods. It's got a lot of it. It's an open source encryption library. And so this appears to be OpenSSL. When I first saw this, I thought, oh, okay, so this program is OpenSSL. But then I was thinking, well, maybe it's just OpenSSL being incorporated into something else. And when you look through here, this is all other OpenSSL type encryption data and so on in here. But I kept on looking. This is all more encryption type text. I kept on looking further down. This is all still OpenSSL type stuff. When I looked far enough, though, I started to see other stuff. This is still more OpenSSL type language. So I was kind of scrolling through this, and I'm just going to search for it. So I had to scroll through this the first time to find it, but I'm just going to search for it to make it easier to find for you guys. So this is the next thing we find is this section, this text section here has some very interesting stuff. These are some function calls that are incorporated into this program, and we notice one of them is this internet crack URL. And then scrolling down a little further, we saw these references to Meterpreter. If you're familiar at all, if you've done any white hat hacking type classes, ethical hacking, you may be familiar with Metasploit. Metasploit is kind of the key piece of software at the core of Kali that's used for lots of different. It's a very flexible tool framework for attacking, for hacking of all different kinds of things. Meterpreter is part of Metasploit, and it's the main sort of remote access strategy within Metasploit when you exploit a machine. So when I see all this Meterpreter stuff, Meterpreter proxy, and I realize that's probably what this is. This is probably Meterpreter, which is a piece of malware, right? It's used by ethical hackers, but anyone can use it. And it's a piece of software, and one of the options in Meterpreter when you use it is to use it to create an encrypted tunnel over HTTPS, which is why it incorporates all that OpenSSL stuff. So all that this is not a copy of OpenSSL. This is OpenSSL being incorporated into Meterpreter. So that's what I believe is happening here. And rather than go through it, I'm going to take out all the suspense and tell you that this second session is much the same. The interesting thing you see here, by the way, is that here we've got our victim machine calling out to the attacker machine on port 443. What do you notice is weird about that? Normally, if you see a connection out to 443, you expect it to be what? HTTPS, encrypted. This isn't. That used to be super common to see attackers do. Back in, I don't know, maybe 10 years ago, 6 to 10 years ago, you saw attackers doing this all the time, because most companies, if you had an intrusion detection system or something like that, you wouldn't bother to look at any traffic that was on port 443 because you knew you couldn't read it anyway. So you would just ignore it, save on memory, save on processing by ignoring that stuff. So the attackers would take advantage of that fact by using port 443 for their connections, even when the stuff wasn't encrypted. You didn't even have to bother with the code to make it really do SSL. You just had to use the port, and it would just go through just fine, because almost any company allows port 443 or connections out to port 443 pretty much on the entire internet, because people need to browse the web. And that's what that is. So other sessions that are interesting on here, this was an interesting session again, because neither one of these is a normal sort of port. So this was kind of an interesting session as well. And when you look at it, the other thing I didn't mention earlier is that the data never mind. Yeah, so when this thing connects, so this is a different thing, and this one was interesting because it seems to be encrypted or encoded in some way, but I noticed something. Most of the transmissions look like this. They have a number. The data section starts out with a number, and then a pipe character. So if you scroll through and look at them, see that pattern. See, there it is again. There it is again. You know, number pipe X. Number pipe X. Number pipe X. Number pipe X. Right, and that pattern just repeats itself throughout this capture. Number pipe X. Right. So I don't know what that is, but it's some kind of code. And this is a pretty short session, but it seems like some kind of probably control code that's going on between the victim and the attacker. And that's my thought about it. Is that's what it seems like it maybe is. Other interesting sessions. I think this was the one. Okay, so this one is SMB. So it's an SMB session. SMB is server message block, and SMB is the normal protocol that's used within Windows to connect to file shares and to other the general sort of Windows talk you see back and forth, like browsing file shares, that kind of thing, is SMB. It's also implemented in Linux as Samba, is a Linux protocol, a Linux program that implements server message block for file sharing and that kind of thing. This was really interesting. This one I'm going to follow the stream so we can see what it does. But basically the attacker is connecting to the victim machine here. There we go. Okay, so, and you know, LAN manager. LAN was the first type of system that implemented SMB. So SMB was originally a native protocol with LAN manager, which is why you still see references to LAN man in here. And NTLM is NT LAN manager authentication. And that's the authentication protocol that's used within Windows very heavily. So you see all these NTLM references. This is the authentication taking place. So this is the attacker. The attacker identifies the machine as running Windows 2000 5.0. If you're old enough to remember Windows, my first version of Windows NT was in Windows NT 3.51. Was when I first started using Windows NT. And then Windows 4 I used really heavily. That was when Windows NT became a really big thing in businesses and stuff. And when they were getting ready to come out with Windows NT version 5, they changed the name and said, well, we're going to call it Windows 2003 instead. But under the covers, it's still called Windows 5.0. And then same thing here, Windows Server 2003. Notice it's just a dot. Windows Server 2000 was 5.0. Windows Server 2003 is actually 5.2. It's just a dot version increase from Windows 2000. So we see these machines talking back and forth. This is the victim machine, by the way. That's Windows Server 2003. So what we see here is we see the attacker trying to connect to IPC $. IPC $, is a common administrative share that exists on pretty much every Windows machine, and there have been vulnerabilities in those administrative shares, and it was a common type of exploit to try to make a connection to these administrative shares and to try to write files even though you might not have a valid username on that system. And some versions of Windows have been vulnerable to that kind of attack. So then we see him trying to connect to two different directories. One's called spools, one's called browser. We go down a little further and we see actually this might actually be, as I recall, this might be actually more easy to see in this version. Okay, so we see the attacker gets a pipe to browser, so he gets an actual connection to that browser folder. Right here he creates it. Here he's trying to create the path. He tries to create spools, and you'll see that the response that he gets is see all that. Okay, he gets object name not found on the IPC. Here he's trying to create browser. He's trying to create that browser subfolder, right? Create. And then the response comes back that this file existed and was opened, right? So he was able to open that, and then we'll see him writing some data to it here. So he's writing data into that folder, and that's what all this other stuff was here. So I'm not really sure what the data is that he's writing there, but maybe we can find out. Maybe we can look on the disk image and see if we find something in a folder called browser, and see if anything is written. So we make note of the time, right? If you want to see the time in Wireshark, you want to go to the time display formatting to actually get a time, right? So use this time and see if we can find anything written in that browser folder around this date and time, right? So I'm going to add that to my notes. I already had in my notes about creating these. I'm going to add the date and time. So it was at 2013, 12/16 at 04:50:45, right? So we're going to look in the disk and see if we can find anything that was written to that folder at that time. And we can also look for files that were written at these times here, and this whole thing is not that long. But these are those sessions where they wrote Meterpreter. We didn't look at the second one, but it really is very, very similar to the first one. So we can look at this time as well. I think the times are all pretty close to the same, right? So 5:46 is when we see the Meterpreter thing. So I'm going to give the date and time for that as well. 04:56:10. Okay, so those are some more things we can investigate. So I'm going to go ahead and wrap this video at this point. That's some more things we can do. We did with Wireshark, and I'll do another video in a little bit on looking at the memory image to support some of these things. Key things you're gonna want to note in Wireshark are the ports, right? Note the ports. The memory capture is from .69, which is the victim. .69 is the victim. That's what we have a memory capture from. So look at the ports that were used on .69. Right, so look at .69, look at its ports. This 25.190, that's weird, especially. That's a weird one. And then it's running a web server on .80, but we want to look for this 1453. Make sure I have a note of that. Yeah, I do. There it is. Okay, so I'm sorry, it's 1648 on .69. Yeah, 1648 was the port. So we want to make note of these weird ports because we want to, 139.445, those are normal Windows ports. So So we already know what's running on those. Even though it can be abused, it's not running in kind of malware. But I'm thinking whatever's got port 1648 open, it's got to be something bad, right? Whatever process that is bad. So we want to take a look at that. So like I said, I will do that in another video.